All right, thank you, Stacy, and good morning, everybody. I'll go ahead and start sharing my screen here, and we'll kick it off. All right, so today, as Stacy mentioned, we're going to talk about AI ethics and digital responsibility, designing for health, safety, and welfare. So a little bit about me. I won't go into too much depth here because Stacy did a great job introducing me. But my name is Wellbe Bartsma. I'm an architect and associate at Gensler here in Las Vegas. And I also currently represent Nevada on the AIA Strategic Council. And to go in a little more depth on that, it's where I've been contributing to the Digital Architecture Study Group, examining how artificial intelligence and emerging technologies are reshaping design, ethics, and the architect's role in society. That work has recently expanded into collaborations with the AIA's new AI task force, helping guide national conversations around responsible innovation. On a more local level, I am the 2026 president-elect for AIA Las Vegas. So in short, I work at the intersection of practice, technology, and professional leadership, and that's what brings me here today to talk with you about AI and the future of architectural practice. So let's dive in. So AI isn't coming, it's here. But what's new today is the kind of AI that we're seeing, systems that can reason, interpret drawings, and make decisions across formats. That's what we mean by multimodal and goal-driven AI. For our profession, designers, architects, engineers, contractors, etc., that changes everything from coordination to delivery. We can use AI to find conflicts faster, explore sustainable options sooner, and manage projects more efficiently. As architects, our primary duty is to protect the health, safety, and welfare of the public. The adoption of AI does not change this duty, it introduces new and complex risks. This course is about how to manage those risks. So we've set the stage for why AI matters right now. The real question is how architects respond, and that's where the AIA Strategic Council comes in. Within the council, our study group on design, artificial intelligence, and digital architecture, that's how our study groups have evolved over the last 3 years, has been leading this work, and I'd like to share what we've been doing. So first, what is the Strategic Council? This isn't the governing board of the AIA, it's a think tank that helps advise the board on relevant topics facing our profession. There's about 70 of us that work in study groups to look ahead at the big issues shaping the future of the profession. So to help kind of ground that, there's about one representative from each state, and larger states get multiple representatives. For the past 3 years, the Digital Architecture Group has focused on AI, starting with exploration, moving to a roadmap, and ultimately drafting the AIA's AI resolution, which passed with a 99% support at the recent annual business meeting in Boston and led to the creation of the AI task force. My own focus has been on this work for the past 2 years, with this last year on a team examining well-being in the profession. So much of what you'll see in this presentation comes from the collaborative effort of this group of talented architects. These are the members of this year's Digital Architecture Study Group, and it's been my privilege to work alongside them on the Strategic Council. Each person here has contributed ideas, perspectives, and energy that shaped our conversations and guided our outcomes. This work is not the product of one voice, but of many, and that's what makes it strong. Our study group set a clear goal for this year to support the AIA's ability to proactively shape industry-wide AI usage policies and frameworks. This isn't just about policy for policy's sake. The aim is to make sure AI adoption in architecture is equitable, ethical, and ultimately beneficial for all members, whether you're in a large firm or a small practice. And part of that goal was to create a set of takeaways that can help members and future architects better grapple with and manage the transformative impacts of AI on both our profession and the built environment. When we think about our approach this year, it really builds on how the council operates through its study groups. Each group takes on a piece of the future of practice, and ours focused specifically on AI and digital transformation. Our process was structured but flexible. We reviewed the work of past groups, identified gaps and emerging questions, and then organized into smaller teams to dig deeper into specific themes. That balance of continuity and new ideas helped us keep momentum while also expanding the scope of what we looked at. Our delivery has always been tied back to impact. How do we support members, create awareness, and shape practical tools that can actually help architects? And we've thought of this work as part of a continuum. 2023 was about initiation and exploration. 2024 was about the groundwork and the AI resolution. And 2025 was about advancing the work and supporting the implementation. So I'll quickly recap where all of this started. In 2023, the awareness and the use of AI tools in architecture was still very low. ChatGPT had just been released to the public. So I know myself, as many of you, if you remember when that happened, did you try it right away? It actually took me a little bit to get into it. And then just think of all the tools that we're using now that have evolved from that. That year was about asking the first questions, often through the lens of new shiny tools and beginning to imagine what AI could mean for design. By 2024, the conversation shifted. We were no longer just experimenting, we were starting to see the real impacts that AI could have on practice. That led to the development of the AI resolution, which connected AI to bigger themes like equity, business, and well-being, and ultimately went to the AIA board with strong support. Our current work this year built directly on that foundation. We focused on advancing the AI resolution, which, like I mentioned, passed with an overwhelmingly 99% approval, and that kind of consensus is rare, and it showed just how important this issue has become for the profession. The resolution also sparked real action. The AIA Board of Directors created the AI Task Force to take on implementation and provide ongoing guidance. That means the ideas incubated in our study group have now become a national mandate. At the same time, we didn't stop and wait for the task force. We pressed ahead, asking the right questions, surfacing member concerns, and tracking how AI and digital tools are already affecting practice today. Looking ahead, our role is about alignment, not duplication. The AI task force is carrying the responsibility for implementation, but our study group still has an important job to do. We see ourselves as a think tank and a bridge. That means continuing to identify the right questions, frame the critical issues, and explore how this work can best serve both the membership and the profession at large. In short, our future work is about staying at the leading edge of AI and digital transformation so that architects and designers are shaping these tools rather than being shaped by them. So I'll dive into our focus areas. Our study group work started pretty broad, exploring AI's impact across practice. But to make progress, we had to narrow in, so we chose 3 lenses that cut across everything we do as architects, which is equity, business, and well-being. So these became our focus areas. When we looked at equity, our focus was on how AI adoption can be made fair and accessible across the profession. Here are the challenges, though. Many firms don't fully understand AI yet, and integrating it into workflows is hard. Small firms especially don't always have access to secure or affordable tools, and if nothing changes, this could widen the gap between large and small practices. So instead of declaring solutions, we focused on what equity in AI should look like, lowering barriers, supporting innovation across all firm sizes, and making sure everyone has access to education and tools. Equity means being aware of these differences and asking, how can AI serve all communities, not just those with the most resources? The more you build literacy and comfort with AI now, the more you'll be ready to use it responsibly and advocate for equitable solutions in practice. So there's a lot on this slide, and it speaks to the depth of our exploration, but I'll break it down more simply. When we looked at business, our focus was on how AI will affect the contracts, services, and delivery models that define architectural practice. The risks are real, authorship can get murky when AI is involved, and liability for errors isn't always clear. There's also the risk of data leakage or intellectual property exposure and a broader public misunderstanding of what architects actually do when they see AI images or text. On top of that, the business model for architecture, already operating on tight margins, faces new pressures. So what needs to happen? We need consistent contract language across the profession. We need to ensure a human is always materially involved in AI-assisted work to preserve copyright and authorship. And we need to train ourselves and our teams to understand the legal and ethical implications of the tools that we're using. The business side shows up in authorship questions. If AI helps with a diagram or narrative, how do you represent your role as the author? These are the same questions firms are asking, just in the context of contracts and liability. So this is what we're starting to address. When we looked at well-being, which I like to call well-being with Wellbe, we broadened the definition of health, safety, and welfare to include digital ethics and environmental impacts. On the opportunity side, AI can play a real role in making our buildings and communities healthier and more sustainable. From tools that tune ventilation and circadian lighting to reduce headaches and drowsiness and help it stay within recommended thresholds, to tools that can help us select sustainable materials or plan more equitable cities. But there are risks with this too. Data privacy and consent are big concerns, especially when sensors are constantly collecting information about occupants. Cybersecurity vulnerabilities in smart building systems are real and should be thoroughly designed and tested to protect occupants from harm. There's also the environmental footprint of AI itself, being the energy it takes to power these massive models, which I will get into later. So what do we need? Guidance that explicitly connects AI to our HSW responsibilities as architects, sharing of knowledge and case studies so the profession can learn together, and training that helps us use AI responsibly and in ways that are energy conscious. This means thinking about how AI can support sustainability and well-being in our work, but also being mindful of the hidden costs. As architects and designers, we need to design not just with people and the planet in mind, but with digital ethics and environmental impacts included as part of that responsibility. As we brought our three focus areas together, equity, business, and well-being, a set of common challenges really stood out. We have to think about data integrity. How do we trust the outputs when AI tools can be flawed? And related to that is authorship and ownership. Who owns the rights to AI-assisted work? There are ethical questions too, bias in training data, equity and access to tools, and making sure AI doesn't reinforce existing inequalities. Legally, the frameworks haven't caught up yet. Compliance, contracts, and regulation are all behind where practice is moving. Another challenge is design thinking itself. If we have to guard against over-reliance on AI so that human creativity and judgment stay central to the process, transparency is part of that too. Many of these systems are black boxes, and we need to understand how they're producing results. On top of that, there are very real issues around skills and training, ensuring equitable access to knowledge. The environmental impact of AI, from energy use to carbon costs, risks undermining climate goals. And finally, the employment impact. If firms adopt AI without planning, it could make it harder to adopt and develop and retain young talent. These challenges aren't reasons to avoid AI, but they're reasons to use it responsibly. The profession needs architects who can ask these questions and build safeguards into how AI is applied. So artificial intelligence is transforming not just design tools, but the physical systems that support them. Every AI query, every training model, every piece of data we generate lives somewhere inside a growing global network of data centers. This new infrastructure has a human impact. It draws energy, water, materials at unprecedented levels, shaping how we think about safety, equity, and sustainability. As architects, we sit at the intersection of innovation and responsibility. We're now designing for invisible users, the people who rely on stable power, digital access, and environmental balance. This next segment will explore how AI's growing footprint is reshaping our built environment and how design can restore balance between technology and human welfare. AI's rapid expansion is driving the biggest transformation in data center design we've ever seen. Facilities that once housed a few thousand servers are now hyperscale campuses with 10 to 20 buildings, each operating around the clock. Power density has skyrocketed from 4 kilowatts per rack to over 100 kilowatts. That's a seismic shift in safety risk. Heat generation, fire load, and power management all demand new design thinking. Traditional air cooling also can't keep up. We're now seeing a shift to liquid cooling systems, direct-to-chip technology, and even immersion tanks. These aren't just technical updates, they change how we plan structure, floor height, and mechanical systems, and more. From a health, safety, and welfare perspective, these changes redefine what building safety means. It's not only about human occupancy, it's about protecting communities from grid strain, fire hazards, and excessive water use. The next generation of data centers must deliver performance without compromising resilience. That means integrating renewable energy sources, designing for modular adaptability, and coordinating architecture with engineering at a deeper level than ever before. AI's environmental cost is becoming one of the biggest challenges in digital design. While the technology offers tremendous potential, the energy it consumes is growing so fast that it's starting to undermine global climate goals. In the last few years, we've seen data center electricity use double between 2017 and 2023 alone. What that means in practical terms is that nearly 4.5% of all US energy is now being used just to power data centers. That's more than some entire industries combined. And the numbers are accelerating. By 2028, AI workloads are projected to consume over half of all data center energy, driven largely by the massive computational needs of model training and real-time prompting. This surge in demand is pushing the limits of even our most efficient systems. Because demand is rising faster than renewable infrastructure can keep up, operators are also turning to less efficient energy sources to fill the gap: coal, gas, and other carbon-heavy supplies. This not only increases emissions, but places additional pressure on regional power grids. These energy costs don't exist in isolation, they flow directly to consumers. As operational costs climb, many utilities are projecting higher electricity rates, meaning the impact of AI isn't just technological, it's economic and social, and will go on to the consumer. Cooling these facilities presents another major environmental challenge. To prevent overheating, data centers use millions of gallons of potable water every day. In water-stressed regions, this competition for resources can threaten community resilience and public health. And even beyond the quantity of energy used, the carbon intensity of that energy is higher. On average, data center electricity has about 48% higher carbon emissions than the US energy grid overall, due to the round-the-clock nature of their operation. To put the scale of this growth into perspective, ChatGPT now ranks as the 5th most visited website in the world. Every single one of those interactions requires energy, cooling, and storage capacity that ripple through this global network of infrastructure. The takeaway is clear here. AI's future depends on how responsibly we design for its energy footprint. As architects and designers, our work will play a critical role in reducing environmental strain, improving cooling efficiency, and shaping infrastructure that supports innovation without compromising sustainability. So when I talk about AI's massive energy use, it's easy to think only in terms of data centers or global grids. So the scale becomes more tangible when we zoom in down to a single interaction. A simple text prompt, the kind we use to ask AI a short question, consumes about the same energy as running a microwave for a tenth of a second, so it's not much on its own. But as the prompts get more complex, the energy adds up fast. A long-form text prompt, the kind used for detailed analysis, draws the equivalent of running that same microwave for up to 8 seconds. If you generate an image, you're closer to 5.5 seconds of microwave energy. And with the newest video generation models, a single prompt can require as much energy as running a household microwave continuously for nearly an hour. That's just one prompt from one user. Now imagine millions of people prompting simultaneously every day. This is where the environmental challenge of AI becomes very real, and why efficiency, sustainability, and design innovation have to evolve just as quickly as the technology itself. So moving on to how data centers are evolving a little bit. They've long existed at the edge of cities, massive windowless boxes that most people never see. But the model is shifting. Today, data centers are being woven into the urban fabric as mixed use or community integrated developments. When embedded within neighborhoods, they can share infrastructure like energy loops, stormwater systems, and public amenities instead of isolating them. Designing facades that respond to context, integrating public art, or dedicating portions of space to civic use helps them become more visible to contributors, not visual intrusions. Adaptive reuse is another major opportunity. Converting historic or industrial buildings into smaller edge data centers brings these facilities closer to users, improves latency, and conserves embodied carbon. Repurposing existing structures not only reduces environmental impact, but fosters cultural continuity and trust. This approach protects both environmental and social health, revitalizing underused neighborhoods while reducing material waste and emissions. It's a chance for architecture to bridge digital progress with civic purpose. As AI reshapes our built environment, architects are being asked to lead in new ways. We're designing not just physical structures, but digital ecosystems, systems that must operate safely, transparently, and sustainably. Early collaboration is critical. When architecture, MEP, and sustainability teams work together from the start, we can predict performance outcomes and prevent design conflicts that waste energy or compromise safety. This holistic approach is how we transform risk into resilience. Public communication also matters. By positioning data centers as civic infrastructure, essential utilities like water or transit, we help communities understand their value and advocate for smarter, safer design. This kind of design leadership goes beyond efficiency. It's about ethics, how we balance innovation with accountability. Architects have the power to define how AI's physical footprint interacts with people, policy, and the planet. AI's energy appetite is immense and growing, as you've seen me discuss. A single large-scale model can consume as much electricity as hundreds of homes over its lifetime. This isn't abstract, it's changing where and how we design. Recent studies show data centers are being built around megawatt scale power systems, making cooling and power availability the top design priorities. That's where architecture becomes critical. We control the form, materials, and environmental strategies that determine overall impact. Energy reuse is one of the most promising innovations. Waste heat from servers can be captured and redirected to heat nearby buildings, greenhouses, or even swimming pools, turning a byproduct into public benefit. It's a tangible example of how good design supports welfare at the community scale. Adaptive reuse also continues to emerge as one of the most sustainable strategies. Historic buildings, with their thermal mass and central locations, make ideal candidates for smaller edge data centers. They reduce carbon emissions, shorten construction timelines, and preserve neighborhood identity. Ultimately, this all circles back to people. Behind every AI tool and every data stream in communities, people who rely on clean air, stable energy, and resilient cities. Designing with empathy means seeing these systems as extensions of our social and environmental responsibility. That's the real human equation in AI and architecture. So moving on, what does AI look like in real practice? Across architecture and construction, we're seeing transformation at every level. In design and documentation, there's generative tools, BIM plugins, early clash detection, etc. In project delivery, there's RFP scanning, submittal review, meeting summaries. I know meeting summaries being controlled by AI have been very helpful for me. There's visualization and analysis, enhanced renderings, early daylighting or performance checks. So this isn't generative, but it's analyzing our own work still. Business development, help with proposal drafting, marketing automation, knowledge retrieval. The point isn't that AI is doing our work, it's that it's amplifying what we as architects and designers already do. So where are we on the AI curve? We're not at the end of AI development, we're at a critical midpoint. The first generation, which was chatbots, gave us the conversational interfaces like ChatGPT and Copilot. Then came the reasoners, which are systems that could problem solve and analyze complex information. That's where most architectural AI tools have lived up until recently. But right now we're entering the agent stage, where AI doesn't just respond, it acts. Agents can perform multi-step tasks, trigger actions across software, and manage workflows. This is the real transformation moment for architecture and construction, where automation begins to connect to real project processes. By 2026, we'll start seeing innovator-level AI, which is capable of generating entirely new approaches, not just options, but insights, solving proofs in new ways, etc. The final stage, organizational AI, envisions systems that can operate almost like firms themselves, managing information, schedules, and even decision chains. The key takeaway, we're right at the transition of AI as a tool to AI as a collaborator. What you see here represents current AI ecosystems most of us are already working with. Tools like ChatGPT, Gemini, and Claude, Perplexity, and Google's Notebook LAM, each of these have their strengths. ChatGPT's broad reasoning and context retention, great for design review, analysis, and drafting. Gemini excels at multimodal understanding, integrating text, images, and data. Claude is known for handling long documents and giving detailed summaries, useful for RFPs or contract reviews. Perplexity combines search and citation, making it ideal for quick research and fact-checking. Notebook LM focuses on context-aware synthesis, connecting information across PDFs, reports, and data sets securely. Llama 3, a language model developed by Meta, great for reasoning, code generation, and instruction following. And GitHub Copilot, coding assistant that helps developers write code faster with less effort. So what's important is that all of these are moving from passive prompting to active reasoning, from giving you an answer to helping you act on it. Across the profession, AI is showing up in almost every part of practice. In design and documentation, firms are using generative tools to explore massing and form, and AI plugins in BIM to catch clashes early. In project delivery, AI can scan RFPs and submittals or even generate action items from meeting recordings. On the visualization and analysis side, AI can restyle or upgrade renderings, and using AI for energy, daylighting, and material performance checks allows architects to optimize building design for occupant health and reduce environmental impact, protecting public welfare. And on the business side, firms are experimenting with AI to draft proposal language, manage marketing, or even create knowledge bots that answer questions from past projects. So the point isn't that AI is doing all of the work, It's that it's speeding up or enhancing nearly every part of what architects already do. Here's some further examples of how AI is being used for taking long, repetitive tasks and making them shorter and sharper. For submittals, using AI for a quick conflict check can identify clashes between life safety systems, structural elements before construction, preventing safety risk to future occupants. In RFPs, when responding to new requests for proposals, AI can compare requirements against previous submissions to identify similarities, relevant content, and missing criteria. This streamlines the proposal writing process, saving time and ensuring consistency across deliverables without reinventing the wheel each time. Reports, AI-driven writing assistants are increasingly used to review and refine reports, offering suggestions for clarity, tone, and technical precision. These tools act as an ever-attentive second set of eyes, helping professionals produce more polished documents while also improving their own writing skills over time. And discovery. In fields such as expert witness or forensic architectural work, AI shows promise for efficiently reviewing large volumes of discovery documents. It can help surface key information, patterns, and potential red flags. However, confidentiality and data security remain critical considerations, prompting ongoing exploration of how AI can be used safely and responsibly in these contexts. A few quick tips. So never take AI's answer as the final word. It's there to identify issues and save time, not to replace expertise. Use it as a time saver, to shorten long tasks, to give you a head start, or to break down complexity. And always remember your judgment, your training, and your professional responsibility have to stay at the center. AI is a tool, not a substitute for thinking. Lastly, I'd like to discuss how the future of practice will help shape by those who can blend technology with humanity. AI isn't just about automation, it's about reimagining how we collaborate, share data, and deliver value together across architecture and construction. So on this slide, when I talk about the human advantage, I don't mean resisting technology, I mean defining its purpose. Our strength as architects and builders has always been our ability to think critically, empathize deeply, and make ethical decisions under uncertainty. AI cannot replicate that, it can only extend it. So as we adopt these tools, our responsibility is to lead their use, not follow it. That means embedding ethics into workflows, asking hard questions about authorship and accountability, and using data to make design more sustainable and equitable. The future of practice won't be defined by who can prompt an algorithm. It'll be defined by who can connect technology to human values. Because at the end of the day, we don't build for machines, we build for people and for the planet. So this was a journey of AI across the profession in multiple capacities. At the Strategic Council, we've been scanning the horizon, asking how AI will change architecture and what we need to do to prepare. The new AI task force is where those ideas are now being put into action with policy, ethics, and resources for members. And in practice, I've talked about how AI is already helping with real-world workflows, submittals, RFPs, reports. And finally, there's you. You're the next link in the chain, and how you choose to use AI will directly shape the future of practice. So here at the end, I'd like to say that on behalf of myself, as well as my Strategic Council counterparts, who I could have helped create this presentation without, and the countless hours of research that we did thus far, I'd like to thank you all. So I know there might be some questions, but I will review those. But in the meantime, I would like to introduce John Derkach for the next portion of this seminar. So if John, you can come on in and we can start the next presentation.
All right. Hey, Wellbe. see. Can everyone hear me all right? Thank you everyone for joining. We really appreciate it. Wellbe, thanks for the intro. Thank you to AIA Las Vegas as well as my team for helping put all this together. So today we're going to talk about your model being a junk drawer. I know that that's a little bit of like an edgy start to the conversation here, but we'll get into AI, how it's currently being used, kind of a little bit about the future, and then some of the things that we can do to protect ourselves as architects. Um, so yeah, let's jump right in. All right, who am I? I'm the founder of Baya, a architectural technology company, along with a principal architect at AbbVie. I work quite a bit on science and technology projects and have computational design background, as well as thrive in data-driven solutions. That is a QR code to my LinkedIn. Feel free to reach out. All right, so a little bit about some of the problems that we kind of face in the industry. And to be fair, these have existed way before AI or kind of many of the technological advances, but um, it's challenging, right? As you're putting together projects, there's a lot of different parties involved. You're trying to balance everything that you can, and then you're also trying to execute on the contracts that you've signed. It is important to note that most projects, especially as they get larger and larger, tend to suffer when it comes to budget and schedule. And as a whole, the industry is pretty inefficient. There are quite a few reasons for this. This isn't just something that's a giant surprise, but as you'll see in the next slide, there are different industries that are able to manage some of the inefficiencies a lot better than we are because they tend to work in a vacuum. But as you have more and more parties involved, things get more and more complicated. And as everyone has a different process, every firm has a different process, you tend to find that there's less consistency across the board. So even though you may work with the same general contractors, different architects will kind of disseminate data different ways. Productivity. These are always fun graphs. It's interesting to see kind of how the data is flowing. And I will say that it is somewhat disappointing to see that, construction and architecture at somewhat of a decline over the last 70 years. Um, Again, there are things that implement or have been implemented which make things a lot more challenging. So as projects get larger and larger, depending on cities and governments and getting permit, there are difficult processes that take quite a bit of time to get through. A lot of these bureaucratic policies really haven't been changed or updated, and I think many people can agree that there's a lot of things that we can do to get permit more efficiently. I will say that things like agriculture and manufacturing, these are industries that live inside of a vacuum. So essentially, you can create a warehouse, and in your warehouse, your manufacturing processes can become more and more efficient because you have control over every detail within the process. So every step in the way. I will say that over time, architects have given up, more and more of the means and methods, as well as the financial components that get built into a building. And so now, as technology evolves, there's a good time to essentially come in and regroup and understand that maybe some of these processes can be vertically integrated into design firms once again. So some of the other things, some of these are dangerous industries like mining. It's pretty challenging. I will say that in construction, industrial construction actually has had a 16% bump in productivity in the last year, which is really interesting and something to definitely monitor as we kind of continue here. All right. So AI utilization by firm size. This actually surprised me quite a bit. Traditionally, you have smaller companies that are more agile and able to adopt new technologies more easily. Um, but in many ways, in design and construction, this has been reversed. And I will leave quite a bit of time at the end for questions so we can kind of jump in. I'd love to hear other people's thoughts on, why this may be. But um, that said, this is also a year old. It's the 2024 data, and obviously we're coming to the end of 2025. So I'm sure that these numbers are drastically different. I would expect them to be, given how quickly things have been moving. So another thing to kind of monitor. So this is how AI is traditionally used today. This was a study that was put out by OpenAI. They've essentially provided their data to the world, and so I will say from the architectural standpoint, you can kind of take like a sigh of relief. The majority of ways that people are using AI really come down to practical guidance, writing, seeking information, and so while this is still kind of that early portion that Wellbe had mentioned earlier, things will change as agents kind of become more and more integrated into companies, and we'll touch on how that's happening and the best ways that you can kind of look into it as a firm, safely, of course. But yeah, I would say that this is one of those kind of interesting slides to kind of remind people that AI really isn't touching 3D, at least not yet. I will say that in general, the 3D that it does touch really revolves around more point clouds and mesh-based geometry rather than like NURBS geometry. So when you look at like a GPU, which is your graphics processor unit in your computer, essentially that unit, which has enabled AI to become what it has today, can take millions and millions of tiny operations that are not very complicated and essentially do mountains of work for you. And that's essentially why you have the immense graphic ability that you do, given the generative AI that is out there. All right. So while we touched on this briefly, I will kind of preface this slide a little bit. It is a little confusing because the annual use for farmland is an annual use number. Training is a one-time use number, and then static volume obviously isn't going anywhere. This was put out by like a few different companies, but essentially what you can kind of see here is it doesn't fill out the entire full picture, but it is important to note. And again, AI isn't like destroying the water. What it is doing is actually using immense amount of cooling, and therefore the water tables in which these data centers are placed, essentially the water evaporates and then relocates to another location. And that's really the big problem here. Not so much that the water is being destroyed or that it's going away forever. It's essentially that the water that comes from a certain area is being relocated to another area, which can cause a discrepancy or an issue in the surrounding areas, essentially. So, okay. So agentic AI. This is another thing that Welby actually touched on. Kind of interesting to see how things have come around. And this is kind of where I'd like to touch a little bit. I know there was a question about how can we be safe about our data. And I will say that of all the industries that are out there, I would say that architectural and design data and information is essentially the safest. And none of it is up on the public internet, which essentially all these models are trained on basically what is open to the public. And so I will say that this is essentially the biggest opportunity for architects kind of ever. We're kind of at that turning point where technology is becoming available to firms that you can implement on your own. You don't necessarily have to use a product. There are products out there that are safe. I will say that Meta specifically, they have open models like Llama where you can actually download them on your desktop and essentially use them in a vacuum. So that information is never leaving your computer. You essentially have full authorship, full authority. You get to basically run that model, any way that you see fit. There are some drawbacks, right? So when you have a model that's completely running on your computer, I guess the biggest drawback is that you don't have access to live data feeds unless you connect your own database. So that's kind of number one on the bigger side here. But you also have the ability to work with large companies like ChatGPT or Anthropic or Perplexity, whoever it may be, to essentially create a corporate shell within that AI system. So your information will still go up to their cloud. There still will be some training, but your proprietary information will not go out the door. At least that's what they promise. And so that is kind of like your two big options for protecting your information. I will say that I'm sure different firms have looked at this in different ways, and I'm sure there are other solutions as well. Some of the interesting things that you'll kind of see, and this data is about a month and a half, 2 months old. So if some of the training and benchmarking that has come through has changed, then we'll probably have to update this next month. But essentially, things like Harvey Law are actually a really great example and case study for architects because essentially, in order to utilize Harvey Law, you have to be an attorney, you have to work at a large firm or work at some sort of legal firm, right? They're not opening it up to the general public. And I think that the way that most professions will kind of continue here is they will have more and more proprietary data that you are locking in behind a closed wall, ensuring that the people that have spent countless hours and are properly trained to actually utilize the data that is coming out of these very, very powerful tools, and essentially keep you locked in, um, basically protecting you. And so I guess we can kind of run through a few of these in case some of the folks aren't familiar. But essentially, Perplexity is a really great search engine. It has fewer agentic features, which is why it's kind of smaller on the graph here. That said, I mean, it is still a powerful research tool, so not to be dismissed. You will see that kind of in the coding world, and I mean, keep in mind, AI does code and it can do amazing things. This is not necessarily super efficient code. It gets kind of the job done, and you can basically create like consumer websites very easily. But when it comes to coding in 3D and coding complex systems, it's going to have some challenges, right? But that said, given that companies like GitHub have provided so much open code that has enabled technology to basically leap forward, you are able to basically train various agents to help you code. And some of them act as assistants, some of them act as agents. So it really just depends on kind of the two. So kind of the winners in that realm tend to be like the Google Geminis, the Groks. Cursor, I believe, is more of an assistant. And then there are different companies that kind of help enable some of the coding that like builds into other applications like Goose. I will say that depending on what your goals are, and this is kind of one of the things that as designers we can learn from the consumer sales marketing side, AI really has taken huge leaps. So you no longer have that constraint on the amount of upfront capital that you have to put in order to market your firm or help out with sales. So there are different ways that you can kind of, essentially use AI as a force multiplier to essentially make your team feel a lot bigger. And again, we touched on Harvey. This is one of those like use cases that I absolutely love because I mean it really protects attorneys and law and ensures that the AI is actually built out safely with accurate information. Because as we've seen, there have been quite a few lawsuits in the legal space where people have essentially cited sources that just don't exist. So citing cases or case law that may not be applicable or has been completely fabricated by hallucinations. And if you're unfamiliar with what a hallucination is essentially something that the AI has fabricated based on either bad data from the internet that has been trained on or bad data that it has synthesized itself. Um, AIs like being told that they've been doing a good job, and so therefore, because of that kind of glitch in the system, you do have some of these interesting things. And so, as far as like the data has provided, and I will note that I do think that there are other applications such as Perplexity and Gemini that do help out with architecture, but Anthropic has officially tested as one of the best trained in architecture information. And again, as Wellbe noted, I would not put out anything that hasn't been hand checked and verified. And then we'll get into a little bit more about how BIA plays into like a data infrastructure layer that feeds some of these AIs later after this presentation. So, all right, redefining resolution. So I would say that we're again huge opportunity. We're kind of in the space where there are still firms that are drafting in 2D, which if that works for you, then fantastic. But there are efficiencies that can be gained in Revit, Rhino, and other 3D applications like ArchiCAD. So we've seen kind of like a huge BIM 2.0 like movement essentially. And I'm sure that many of you have seen a lot of these applications that are coming out. Many of these applications are web-based. They are essentially built in the cloud. There are many efficiencies in doing it that way. I will say that I think that that is still a bit of a ways off. And I mean, even Autodesk is coming out with several cloud applications, which you can kind of do early design. And one of the things that you'll notice is, given all of the amazing technology that's out, I still think that most software engineers don't fully understand what architects do. And so, like that lack of education on how kind of buildings actually come together, um, is really not out there. And so, therefore, um, some of the solutions may miss certain bits and pieces. Um, but that said, the machine vision and some of the applications that are coming out are quite impressive and can kind of essentially help out with some hacks along the way. So again, early design, generative design, this is where you're going to see like a lot of the big leaps. And going back to this slide, much of the writing proposals, even ingesting and sending out emails, that type of information is definitely big. Um, and again, I'm not trying to downplay the benefits of early design. I just want to kind of note that that's essentially where AI is right now. Okay, so this is kind of one of those big things, right? How do we ensure that we're getting good data? One of the funny things here is even with large manufacturers and some of the products that you see online, they may have a typo in their system. So you never actually know. I mean, most larger manufacturers will have a good data stream, and you'll be able to look up a spec sheet and ensure that there aren't mistakes. But I mean, I've seen dozens of spec sheets with typos even. And I think it's important to note where we've started, what we've been through, and then kind of where things are going. And so essentially, what we essentially started out with were printing presses and books, and that static data you could essentially um, build some sort of idea based on the author whether or not that data was good. And so obviously, like anything, there's a lot of things that are printed that aren't relevant or may not be good data. This is also the most difficult to find things, right? So you have to get through an entire book to essentially absorb the information. And then the internet came around, obviously enormous leap. And I would kind of relate AI very much to the internet in many ways. It's kind of like the next evolution in technology. And so therefore, when you're looking at the internet, you have quite a few websites that are irrelevant or not based in reality, or working on bad data. And then there's also the component of noting that some information that you are pulling in uh, may be essentially adjusted slightly to make numbers look a certain way. So it's funny how you can take data and make it kind of fit towards the needs that you were looking for, which isn't necessarily a good thing. So that's kind of one of the challenging things with the internet. It's like some good, some bad. Overall, more access to information, and access is fantastic. Access to knowledge, I think, is always good for the public, right? Ensuring people can have the information they need to critically think and make decisions. The next step, and this is kind of where things get really interesting, is really like validating data. So the interesting thing, ironically, is that depending on the type of data that you're looking at and different AI data sets, essentially, we can actually take proprietary data as architects, essentially make the connections not only in 2D, but also in 3D, and essentially say that, make some of these huge leaps that weren't actually possible earlier. And so that's kind of where things are going, and really understanding that based on proprietary data feeds that are coming in from manufacturers or your own specific firm, being able to validate that information in order to trace it, have full transparency across the board, and then basically get it to the endpoint, the designer, the architect, the final user, and allow them to make informed decisions. And so I think the big thing here is really understanding that instead of just designing without, I guess, full transparency into every little nook and cranny of your model, you can kind of start building out this essentially results-based design where you can come in and validate, even if you're doing everything by hand, validate some of the information that you're inputting into 3D. So again, um, amazing technology that's coming out. Just because you have like the current technology that like Revit, for instance, which I would assume is the most common. One of the interesting things that's coming out are more and more plugins are coming out as AI is pumping into your design applications. There are quite a few things to look out for. And so I would say that even though you have an AI that's coming in, and I would say if you start giving an AI a prompt to say like just design anything, obviously you're going to come out with very poor results. That said, if you can feed the data that you know is accurate into an AI and essentially ensure that it's only using that information, that's when things get interesting. And that's when you can essentially say, okay, well, this is what I want to design. This is what I design all the time. And then essentially creating the tools around each type of product that goes into your model. And this kind of jumps leaps and bounds once you get into buildability, cross-checking your model for accuracy, for efficiency. Nobody likes opening up a Revit model that takes 30 minutes to open. So like really getting into some of the things that will make your modeling better, make your final product better, and ensure that your clients are happy. I think one of the things to kind of remember is that every time that you are getting like an RFI or a change order, um, those are basically questions about what you're putting together on paper. So excuse me. So essentially, if you had more information piped into your 3D model, and if you had more information in general about the products that are going in, especially things like cost, lead time. Unfortunately, architects have been divorced from cost for a really long time now. That's kind of been handed over to the general contractor. But I will say that AI will completely transform pre-con, the way that we're bidding on projects, as well as the way that RFIs kind of come through. You no longer have to wait for a GC to tell you whether or not a product is going to be available. That information is going to be piped right into Revit. You're going to have that right at your fingertips, and you're going to be able to say, okay, based on the performance or sustainability, I'll be able to make an informed decision about the product that's going into this. I'm going to be able to ensure that I don't have to redesign this because it is to budget automatically, because essentially you'll have live feeds coming in. And just because you have live feeds coming in does not mean that your data is also going out with those live feeds. So again, it's one of those things where you have to be fully transparent with the companies that you are working with. Ideally, you want to vet the technology that you're implementing into your system. But I do think that the way architects are designing, the way architects are putting things together will change drastically. And so that's kind of one of the things that come into this zone here. Okay. So again, touching on the performance-based outcomes. Uh, right now, most folks are not coming in and calculating the exact amount of embodied carbon, the exact amount of recycled content, indoor air quality, or the cost of a project, right? These are important factors that essentially your clients want to know. And it's kind of a shame to not have an answer for them when they come in and ask, well, how long is it going to take to build? Or how much is this going to cost me? Or is this sustainable? Is this good design? Being able to pipe in some of those live analytics, localized to your computer and your 3D model, that's going to become more and more important. And it's really going to differentiate you from the rest of the market. And essentially, this is the biggest opportunity to come in and say, hey, we can design better. We can cut out a lot of those, revised drawings that you may not be getting, enough fee for because you're constantly redoing. It'll make your clients appreciate you more. And ultimately, we'll get to a point where we can have very, very sustainable buildings. And I hope that given the problem solvers that we have in the architectural community, that data centers will become um, essentially net zero. And there are some data centers in Europe that have made that claim. I think that claim has yet to be refuted, but there will need to be kind of a full evaluation. But it is possible, right? Like all of these things are possible. As hardware gets better, as compute gets better, as energy generation becomes better, all of these things are very, very powerful and possible, right? And I'm sure that AI is going to have a big thing or a big component to play within that truth seeking experiment to find those solutions. All right. I'm gonna briefly talk about the rendering side of things. Obviously, we've all seen things like Nano Banana, ChatGPT, the dozens and dozens of rendering agents that are out there, the generative design components. This data is amazing. I think it's incredible for early design work. But as you kind of get further and further in the project, a lot of these renderings are kind of losing some of that value because you're not actually rendering the real thing. So how do we render the real thing? Well, again, coming back to that slide where we were talking about the multiple layers behind BIM, BIM no longer has to be like a dead model. So when you download a BIM model, you no longer have to say, okay, well, now if someone's copying that from another project, or if I'm downloading it once, like maybe the sustainability changes from a manufacturer, we're actually discussing this right now with a very large manufacturer. They've essentially become more efficient. And so therefore their sustainability numbers have come down. And as they revalidate these numbers, the sustainability changes. And so let's say you're working on a large project, you're 6 months into design, and all of a sudden you have to recrunch a bunch of numbers. Well, your client doesn't want to hear that you have to redo work. You don't want to redo work. It's demoralizing to constantly redo the same thing over and over. Instead of that constant refresh, what you could do is essentially plug that 3D model into a live data stream and allow for validated, current, accurate data to come right into your 3D model. And not only that, you can essentially tabulate and use calculators to come in and tell you more insights about your model than you've ever had before. And so that's why I'm more bullish on technology. And again, not all of these solutions have to be AI driven. So not all the solutions are, but I will say that there are quite a few solutions out there that will actually help you design better and actually get you the information that you should have from the beginning, right? What's next? So I would say that like AI scheduling, really understanding how projects are coming together, bidding, some of the things that mostly GCs are responsible for, will become more vertically integrated. And so as you're constantly handing things off, and again, I think there were some comments about how to protect my data and my model. I think most often architects are pretty resilient to send their models out, and for good reason, right? You need to protect your IP. The best way to protect your IP is essentially to derive the data that they need, and push it out, and essentially giving them the information they seek without taking on your details, your proprietary methods, all of the hard work that you've put together for the last 20, 30, 40 years creating these firms. Um, so I think this is kind of where the biggest force multiplier is really going to come into play, and like really connecting systems, and really being able to understand databases, how things are connected, live data, like all of that is going to be one of the biggest changes that is coming in architecture. So really important to note, but I guess one of the best examples that I can provide is, we've been working on a project where a GC has wanted to use different materials, different products, but instead of coming in and just taking their word for whether or not they can actually acquire the products, or maybe there might be some issues with supply chain, being able to pipe in direct information from that manufacturer stipulating that your products will arrive on this date, and adding it into a schedule that's live connected, will essentially cut out most of the RFIs and change orders on whether or not a general contractor can get a light from wherever they're producing it. And so I think understanding where things are produced, where they're shipped from, how long they take to manufacture, those things will be piped directly into your construction schedule. So that's kind of one of the things that I'm the most excited about, and looking forward to. All right. How do we actually implement AI into our firms? This has been essentially the pull on how most Fortune 500 companies and larger companies are actually implementing AI. You can go through and kind of read each point here. This is a survey, so keep in mind that this is opinions from certain people at companies. It's not necessarily what an entire company's AI strategy may be. It just may be from like specific departments within a large company. I will say that as time goes on, the gap between good technology and design and AI and these agents and the way that you implement it into your firm is getting wider and wider. So it is something to really like hone in on, understand, and see if it is something that you want to be implementing at your firm. I think one of the big questions is, how do you do it, and what's the safe way to do it, but ultimately, um, what is the benefit to you, right? Because if you just look at the cost without any of the ROI at the end of the day, return on investment, um, it really doesn't make sense. But if you are honed in on like a specific goal, and if you have a specific idea on how you want to implement AI in a safe way at your firm, then what you can do is you can start dabbling with it, get folks trained on how it works, how to implement it. But not only that, your teams as creative people will essentially come in and say, oh, well, we've been using AI in this kind of department in this way. Maybe we can implement it in another way. I think one of the easiest ways now is most folks kind of fear that whole coding, computational design aspect, but with agents, piped directly into Grasshopper and Dynamo, you can actually do the coding automatically. It may not be the most efficient, but it'll essentially get the job done. And so like really understanding that and understanding what kind of outputs you can gain and what kind of efficiencies AI can actually build out for your firm, really important to at least understand and know that they're out there. And if there are questions, feel free to reach out to me. I'd love to talk to your firm and kind of jump in a little bit more on specific use cases. Okay, so that's a little bit about I guess that's the end of the continuing education portion. I'm going to run just a quick video here, um, give you kind of an idea, and then we'll open it up to some questions. I'd love to kind of have more of an open forum. So essentially, this is Revit. What we've created at Baya is a plugin that pipes directly into Revit. One of the things that we're very proud of is the data that gets pushed into Revit is 100% accurate. We're coming directly from a manufacturer and linking their information directly. So there's no space where you can kind of like lose information along the way. And then that information is piped in. I'm going to back up for a second, is piped directly into calculators. So you can tell exactly right in that instant moment with live feedback, how much embodied carbon, how much recycled content is inside of your building. And then depending on your location and the subcontractors and the materials that are going in, like what does your building actually cost? So answering a lot of those questions that owners like to ask, that we tend to say, oh, you're going to have to ask the GC. So one of the biggest things I think is, instead of spending a ton of money on environmental consultants, like having that information at your fingertips. Let's try different materials. Let's put in different things. Let's understand what is the impact of that material overall. And one of the very interesting things about AI and actually building out data and understanding how these systems work, you can actually start implementing things that aren't traditionally calculated. So typically when you're calculating embodied carbon, sustainability data, recycled content, you're not actually taking the trip into account. I mean, some people are when you have like the full LCA and the full view, but others aren't. We can actually get very specific depending on where the products are being shipped in the country, whether or not they're coming from overseas, and actually start making better and better tailored data specific to your project and the location of where people are shipping things. On top of that, when you have a live feed of the information that's coming into your model, you no longer have to have a junior designer sit there and copy and paste information from a manufacturer's website. That information is always updated. It's piped directly into your schedules. When something changes in the manufacturer's information, that information comes directly through. So you have that single source of truth and that thread of data that is coming from the manufacturers to yourselves, and then ultimately out to the GCs. So pretty interesting stuff, kind of the future of how things are coming together. And then again, how do you take that data out of your model and be able to basically take it and export it and do your own analytics on the sustainability of the building. Um, on top of having just the metadata that's live, including lead times and costs, which are always fluctuating and changing. One of the things that are really important to integrate into BIM is actually the 3D materials. So you may have just one person at your firm that knows how to render really well, or you may be outsourcing it and spending a lot of money, at some rendering company overseas, or even domestically, but it is very expensive. It's a time consuming process. It may take a week. Um, we can actually take the scanned products, make the 3D materials based on those scanned 3D images, and then essentially pipe them into your model in 4K, completely immersive. I mean, you could put on a VR headset if you wanted to. And again, like this isn't something that's generated in the cloud. This is something that you're generating on your computer. So you have full autonomy to your data, your renderings, your information. That this isn't like something that's being trained backwards. It's something that only stays within your system. And I think that's kind of one of the things that architects have the biggest opportunity to maintain is your data is not out there. It's not out there now. AI does not understand NURBS all that well. There are some aerospace companies that are building out like pretty good NURBS parametric modeling within AI, but um, those are few and far between and very, very expensive. So kind of some of the things to know. But the reality is when your client can see the actual product, the rendering of the actual product in high fidelity and be able to walk around their model, you're able to make decisions more quickly. Your clients are going to know exactly what's going to get built out, and you look considerably better being able to say that you don't have to ask somebody else for information. It's coming directly to you. So yeah, that's a little bit about Baya. I want to thank you again for having me. Thank you for coming through this data. Again, if you want to look into Baya, here's a QR code that you can jump in, sign up for the wait list. One of the things that we're doing at Baya is we're only allowing architects and designers, interior designers, PEs to have access to design tools. So just like Harvey, which is an incredible use case, we are protecting the tools and information that we're building into the system and only providing it to designers like yourselves, licensed architects, licensed interior designers, licensed professional engineers, because you've worked really, really hard to get through. It's a good thing to basically ensure that you're protecting yourselves. And so now I don't know if we can jump into some of the questions. Or Wellbe, I see you joined. I don't know if you want to kind of pop in here.
Yeah, first off, can you all hear me okay?
Yes.
Okay, perfect. Sorry. I know I did get a few questions regarding my presentation, so I will jump in with a couple there. Um, One question we received was, it sounds like they need passive house levels of efficiency. This is regarding data centers. Yet I'm seeing more focus on like photovoltaic solar than on making the buildings highly efficient. Is there someone working to educate the data center developers? So regarding that, I say I can't speak for everybody, but at least for the especially with Gensler and other firms I know that do work with data centers and research that's been published. Um, that it's about a mindset shift. So from developers, if they're still focusing on just how's the servers, it's shifting that mindset to how can we optimize at every scale? So including the site, the building, the systems, the materials, for sustainability and community benefit. Um, we want to teach that the site selection and the site strategy, they're part of the sustainability playbook regarding like brownfield reuse, ecological restoration, and landscaping, even as part of the strategy. And the more sustainable they help make these centers with the amount of energy that they're using, I know that's also more ROI for the developer because they're very high performance. So the sustainability gains can be significant when they're properly designed, and they can set new benchmarks.
Yeah, so I'd like to touch on that as well. Couple interesting things that I've seen. I know Google specifically is actually putting data centers essentially at the bottom of the sea. So you have underwater data centers, which obviously the benefits there kind of you have that cooling efficiency. It is more challenging to work in a data center that essentially is underwater. So that's kind of one of the problems. The other really interesting one that I've seen is essentially data centers that are in outer space. So enormous solar, PVs, and essentially space is very cold. So the cooling aspect is no longer an issue. Um, so that's also been a super interesting use case. I think that one's still kind of a ways off. So we'll see how that kind of comes together. But they are pretty interesting to see. There are creative ways that things are coming together. And if you think about it in general, your brain essentially runs on 20 watts, right? And GPU will run on something like 500 or 600 watts. And so as hardware gets more and more efficient, you will actually have more efficient systems and will require less energy. And so it's only a matter of time. And I know that even NVIDIA's chips, if you look at chips from 3, 4 years ago to now, they have drastic improvements in energy and efficiency. So.
All right, I have another one here. Um, how important is it that data centers have exterior envelopes that well insulated and have good air and vapor management layers in their exterior? So about just the insulation of the buildings themselves. Um, so I'll go first on this one, but as well, every bit of efficiency is going to help with this,
Yeah.
of course.
Yeah.
Design solutions that can ultimately make data centers more efficient as we couple more and more systems. Um, Data centers will get better and better. So it kind of goes with the previous question as well, with just making them more sustainable and efficient will help in the long run, especially with operational cost. And I have another as well. This one's a bit more interesting. So it's how will AI change the standard of care? Is it possible that architects who don't use AI for safety checks will one day be seen as negligent? So for what I would answer this as, that the answer is most certainly yes. The standard of care, because it's legal and ethical bar set, by our licensure requirements, for what a reasonable and prudent architect would do in a similar situation. So I wouldn't say it's just static, but it evolves with technology as well. So I would say with AI in the next 5 to 10 years, when we're practicing it all the time because it's just going to get more and more into our workflows like using an AI-powered code analysis and clash detection will become normal. Um, and then it'll become where if an architect fails to use that and it doesn't catch, and they don't catch a critical life safety violation, they might be seen as how come they didn't use AI to help catch that. Granted, when you do use AI to do a performance check, it should always be back checked and confirmed by your eyes. So I do feel it will become industry norm that using AI will become part of standard of care. So it's a profound shift that our HSW duty will soon probably require us to adopt these tools to help protect the public.
I will also say that, like Welby said, we're nowhere near that point yet.
Mhm.
So, there's still quite a bit of time, and I think this is essentially the time to discuss these topics. But it may also not fall completely in the architect's hands, right? So it may be something where local AHJs are actually required to do the AI check on life safety and provide comments before a permit is issued. So, there are a lot of things here that are still at play and still up in the air. So you don't know exactly how that's going to come together. And I will also note on like clash detection, there is a future where clash detection will no longer be needed because you are using tools that essentially do not allow for overlapping geometry and better coordination in general. So I will say that some of the things that we're very used to may actually go away. Some of the things that you're spending a lot of like your high risk, low reward time on will actually transition to more of the high reward, more industry thought type thinking. So kind of I would say you just have to keep up with the times essentially right now and see what people are implementing. Okay, so
Okay,
there's a question
go ahead,
on
John.
yeah, yeah. Can either of you forecast or anticipate the use of AI by building departments or authorities having jurisdiction for the plan checking of project submittals? I think I kind of touched on that a little bit. But I would say very slow. As we've seen with government and adoption and actually passing laws, these things take a really, really long time. And ultimately, the tools will be well established and available before they're actually implemented. So again, one of those things that, chime in, make sure inform your leaders, especially reach out to Wellbe because he's going to be representing Nevada. So, yeah, I don't know if you have anything else you want to touch on that, Wellbe.
Nope, that's good. I have another one here. So it's you framed AI as an HSW duty, but isn't it really just a more advanced productivity tool like Revit or CAD? And how? So why is it different that it requires this level of HSW scrutiny than other softwares and programs that we're already using? So for my answer on this, I would say it's the difference is decision making. So like tools that we've used until now, like CAD, Revit, um, programs like that, when you're the licensed architect and you make a decision, you draw it. So it's a one-to-one extension of your professional expertise, essentially. So what you want is physically what you're seeing on these programs, where AI is probabilistic, where it hallucinates. So you give it a prompt, it does its best to answer or draw or do what you're wanting it to do. So it's guessing the best possible answer based on its training. So it's a little bit augmented. So it's replacing the human decision-making step. So that's why we need to always review what AI is doing. And then if it needs revised from that, we can manually do it or prompt it, hopefully to be correct, but it needs that final review. Um, but it can't really explain why it made a choice. So that's where the HSW factor comes in. Um, Another example I can think of is you could ask AI to optimize an egress path. The training data could be flawed or it hallucinates a calculation. It could generate a non-compliant or unsafe path um, because it's introducing this kind of black box of decision making. So it creates a new category of public safety risk. So it moves AI from a simple tool to a co-author that the architect is still 100% legally and ethically responsible for. So that's why our HSW duty of care and our practice management must evolve with this technology.
Yeah, and to kind of add on to that, I mean, we're still again super early. We're really at we have better access to machine learning and AI. And as products grow, a lot of the things that will be touched on will be implemented because they need to be.
I have another I can answer here. Um, So this one, who is legally liable if an AI generated design fails and harms an occupant? Is it the architect, the software company, or the AI model developer? So who's liable for all of this? So this is a critical practice management um, HSW question, really. Um, the answer in the end is always the architect. AI is legally considered a tool, so it's no different than a calculator or a software package. Um, so in the end, the AI model developer is protected on their end because we are taking legal responsibility to use that tool. So in the end, it's the licensed architect who's regulated and ethically bound to protect the public. So that's why we have our stamp. The architect stamp seals the design and signifies that it's taken full legal and ethical responsibility for the public safety and welfare. If you want to add anything to that, John, or you think it's good?
Yeah, no, I think you're 100% right. Again, always read the fine print. I would say that nearly any software application that you use right now, including Revit, will essentially take zero liability. They are saying that in their terms and conditions, no matter how you use the product, they are not liable at the end of the day for, the end result. So again, implementing that team or that person that is responsible for your QA is going to be really important. And I think it's actually one of the like new positions that will be created in this kind of new technology evolution is essentially the folks that are coming out and reviewing drawings and really bringing like that base knowledge to the profession and ensuring that what you're doing is actually going out in a safe way because as well be noted, you are responsible and it's really important to ensure that you're protected.
Okay, I think I might do one more here. So it's brought up about liquid cooling fire safety. So we want to be more specific. So what are these fluids and how are they worse fire risk than a typical electrical fire when they are liquid? Um, Let me think. So typically with AI racks and data centers with cooling, the racks that are, around over 100 kilowatts now, that's the norm. It's too hot for air. So a new solution is immersion cooling. I know we briefly touched on that, where it's literally submerging the servers in vats of non-conductive fluids. So they're often like fluorocarbons or synthetic oils. So that risk, that brings up the fire suppression, where these oils, they are combustible. So if they ignite, they're a massive fuel source. But because they're not water soluble, traditional water-based sprinklers are less effective at suppressing that fire, and toxic gas. So it's a bigger danger in a fire with some of these fluids. They can decompose and release highly toxic and corrosive gas. So it's an immediate threat to occupant health and first responder health as well, and can also destroy the building. I don't know if you have anything else to touch on that, John.
No, I mean, you nailed it, honestly. I will say that, the way that hardware exists right now will eventually change. Every year it gets significantly better, which is why it's really challenging to have like the legal side and the fire safety side keep up with data centers because we're constantly implementing different hardware and ensuring that that hardware is, efficiently tested. I know that, some of these data centers are actually implementing chips and then they're overclocking them. And so there's a danger and risk involved in doing something like that. And a lot of times that's something that I would say almost every single time the architect will have no knowledge of. So, some of these risks that are kind of popping up, you really have to understand and essentially almost put into your contracts that you are designing for certain use cases without allowing for that overclocking or that overuse because when you overclock a GPU, you're essentially pumping more energy into it and then using it beyond the manufacturer's initial anticipated use case. Um, just because you can do it doesn't always mean that you should. Sometimes there are use cases where it does make sense. Other times there are not, I would say.
All right. I see another question in the box. It's how do you see interior design documents moving forward with AI? So I'll go first on this one briefly. I just know some parts of interior design just by training, but using AI to help fill out specifications and helping that tedious task become faster. I kind of briefly touched on that more with like submittals, RFPs. It's kind of a similar format for specifications with architecture as well. But again, with all the information needed in a spec, there's so much important and prudent information. So it's, highly critical for back checking. But I know AI can definitely be used to help fill those out and get all that information in a more timely manner because I know specifications are tedious. Um, that is more from my background knowledge. John, I'll let you answer if you have anything to add.
Yeah, I think the biggest transformation is going to come in the shape and form of hard specification. So as you have more information at your fingertips, you're going to be able to basically, fight back and say, oh no, like this product is available, or this product meets the needs of the building. It conforms to all the building codes and fire codes and life safety. I will say that you're going to have more detail down the line. So instead of just taking a hatch and pretending that that is a specific thing, you'll have the actual 3D thing along with the intelligence behind it to say, this textile or this product will require this type of adhesive, and whether or not that product is dropped within a wet space, such as a locker room or shower or dwelling area that requires it, you will actually have the adhesive and notes behind that automated within that system. And so essentially, it's going to act as a force multiplier to basically help build that connection that is 100% accurate and not necessarily built out through AI, but essentially enabling you on your end to create that set of rules based on, hey, at my firm, when I specify this product, um, X, Y, and Z will happen. So very much like if this, then that, you'll essentially have rules around the way that you code. And that's kind of what I was trying to touch on when I noted on the generative and parametric functionality. And the big thing to note there is having full control. So essentially having the tools at your disposal to essentially edit any specific point along the way and be able to control that process, right? Because whatever is implemented in AI, you want to make sure that whatever system you're using, you have full control over that, right? So if you implement something that is like a smart BIM object that's going to fill out an entire space or like put up a product of any type, you want to be able to edit the tags. You want to be able to edit the information in there. You want to be able to edit the way that that product is placed within your 3D system because ultimately you are responsible. It is your 3D model. And there's no reason why any of that should be taken away from you.
All right. Another question we got in here, and then we might start wrapping it up. Can either of you forecast or anticipate the use of AI by building departments or authorities having jurisdiction for the plan checking of project submittals?
Yeah, I mean, in my opinion, this would be a dream. And honestly, I don't even think it needs to be AI so much as it needs to be basically like a live check within your 3D model. So, I mean, in many cases, what would happen would be like an AHJ designs a system where they actually have a plugin, and it's done on your computer. You can check everything, and then you submit your set of permit documents. Um, I think that that would go light years in the sense of for the industry, because as you know, if we can actually build more, then you'll get more projects, and costs will continue to come down as there are more efficiencies. I think one of the things that's really challenging, especially if you have a small architecture firm, is like really being able to scale your practice and kind of grow and grow. And I think a lot of that is traditionally hampered by like those really, really tedious tasks that are challenging to implement right now when they really don't have to be. Like the technology is out there to make things better. But I will say that HJs should adopt this sooner. They won't because it's very challenging for a state to come in and say, hey, we're going to change the law. You have to wait for the right meetings. You have to get the right votes. You have to make sure that you're, speaking to your senators. I will say that, you are very fortunate to have folks like Wellbe that are fighting on your behalf to make sure that you have a voice in these systems. And I would say that that is something that should be implemented. Um, but not only should it be implemented, it should be designed by architects and designers. It shouldn't be just left up to the government because they don't even know what they're looking for half the time. That said, we can build safer and better buildings using these tools.